our second video tutorial about kinematics, and this time we studied about graphical analysis of motion. So our focus will be on one-dimensional kinematics, and we'll focus on displacement time graph, velocity time graph, and acceleration time graph. Let's start. So remember that we have to consider this case number 1, wherein the object is not moving or it is stopped. What would be the graph would look like? And case number 2, we have positive velocity and zero acceleration. Case number 3 would tell us about negative velocity and zero acceleration. Case number 4, we have positive velocity and positive acceleration. And case number 5, we have negative velocity and positive acceleration. Case number 6 would be positive velocity and negative acceleration. And case number 7 would be negative velocity and negative acceleration. So we will explore more of this. Now, there are 3 types of graphs that we have to observe. We have first a displacement or position versus time graph. And if we're going to look at it, this displacement versus time graph, we could have a line or a slope out of it. Now, if we have this first representation in math, the first point we have x sub 1 and y sub 1, this would be the first ordered pair, and we have this x sub 2 and y sub 2 as our second ordered pair. We could represent our x sub 1 to be our first time, or the time 1, and the displacement would be our d1. Okay? And on the other ordered pair, we have x sub 2, and that is t sub 2, and the y sub 2 would be our d sub 2. Now, representing this, the equation of the slope is simply slope, or m, is equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Changing this into its corresponding value, the all y will be represented by d, which means displacement, divided by the time, and displacement over time, we all know that it is a velocity. Therefore, in position time graph, gradient or slope represents the velocity. So we have to take note of that. The slope represents the velocity in a displacement versus time graph. Now, another graph that we have to observe is what is known as the velocity and time. So we call that as velocity time graph. And substituting that, we have this first point, x sub 1, y sub 1, and then let our y values be the velocity. And another ordered pair would be x sub 2 and y sub 2. And let these values would be time 2 and v2. And representing our slope formula, we could have acceleration. So remember that v sub 2, or the velocity divided by time, will always represent an acceleration. So, in velocity time graph, gradient or slope represents the acceleration. So we have to take note of it. Okay, another graph that we have to observe is we know as acceleration versus time graph. So we have to take note of this. So from these 3 graphs, distance time graph, velocity time graph, acceleration time graph, we have to observe what is really happening as the object or the car moves on. So let's explore more later. And this time, let's try to recall our slope. In mathematics, we have different kind of slope. We have this positive slope, and then we have negative slope. Okay, and we have zero slope. Let's say it is constant, and the other one would be slope is undefined. Of course, let's try to examine the man while he is in negative 5 meters. Let's try to see what will happen. So the man stays here in a position time graph. That line stays flat. How about if we're going to position that man in 0 meters. Let's try to see what will happen. Okay. Still, the line that is being produced is flat, but this time it is on 0 meter. Now, how about if we're going to position that man in positive 4 meters? Let's try to see. So, in positive 4 meters, that line still flat. Now, let's try to examine zero acceleration but positive velocity. So let's try to position the man at 0 meters. Oh, let me change it. Let me make it into negative 5 meters. And then the velocity would be positive 2 meter per second. Okay, take note we have zero acceleration. What could be the graph? Let's try to see. Okay, now, meaning to say, the man is moving at 2 meter per second. Now, if we try to analyze the graph, it has, in a position time graph, it has a straight line. However, in velocity time graph, you can see that it has constant velocity, which is 2 meter per second. So therefore, we can see that there is no acceleration, so still, this line stays at 0 0 meter per second square. Now, take note that if it is a straight line in a position time graph, it is having a positive velocity. In a velocity time graph, it will be flat at positive 2 meter per second. Let's try to examine now if the man has still zero acceleration but negative velocity. So let's try to position that man in positive 5 meters. Then the velocity is at negative 2 meter per second. Take note that there is no acceleration yet. Now, let's try to see what will happen. You can easily recognize that in a position time graph, it has a negative slope. And in a velocity time graph, it is on the negative 2 meter per second. And still, the acceleration is 0 meter per second square. Now, in summary, in a position time graph, if we have negative velocity, it will have a negative slope. While in a velocity time graph, it will only have a straight line, but it is placed at negative 2 meter per second. Now, how about if we have positive acceleration and we have positive velocity? Let's try to see what will happen to the position time graph and with the velocity time graph. Let's see. So I position my man at negative 10. The velocity is positive 1 meter per second and the acceleration is 2 meter per second square. So, let's play. Okay. As we can see, the man is speeding up. It changed in acceleration. Now, if we're looking for the position time graph, you can observe that the line that is being produced is curved. So somehow it approached a parabolic graph. However, in a velocity time graph, we can see that it has a straight line. Meaning to say, it has a positive slope. So, when it is accelerating, it will produce a positive slope in a velocity time graph. But if you compare it in acceleration time graph, since acceleration is constant, it will have a constant value at positive 2 meter per second square. So in summary, in a position time graph, once it is speeding up, it has positive curve. In a velocity, it has positive slope. And in acceleration time graph, it is still flat, but positioned at positive y value. Now, this time let's try to observe if we have positive acceleration and negative velocity. Let's try to see what will happen. Let's play. Now, we could observe that in a position time graph, it is being curved in a negative manner. And then afterwards, it becomes positively curved. Okay? And in a velocity time graph, take note that it is in a straight positive line. Okay? Now, and acceleration now here is in 2 meter per second square. What's happening here is at the start, there is a negative velocity. But since we have a positive acceleration, we can notice that it changed in velocity, and then therefore from negative it changed or shift in position, that when it reached its positive velocity, it changed in direction. So you could notice that the man changed the direction. First he's going to left, he's going on this side, and then afterwards is going on the other side. So take note of this position time graph, velocity time graph, and acceleration time graph. Now, we have to take note that in acceleration time graph, it is still flat because we have a constant acceleration. How about we have positive velocity and negative acceleration? Let me position my man at 4 meters. And then his velocity is changed to 4 meters. And his acceleration is negative 2 meter per second square. Let's try to see what will happen. So initially, the man is going on the right, and then he slows down, and then afterward is now going to the left direction. But what can we observe with the graph in position time graph? So he first goes in a positive direction, okay, and then afterwards, since we have negative acceleration, therefore the velocity becomes 0, and then therefore as the velocity becomes 0, the man changes into direction because the man is going to the left. So what will happen here is the man in a position time graph, it now shifted into negative curved. Now, take note of the velocity, that we started at positive velocity, then it ends up in negative velocity. So therefore, we can see that the acceleration, as it represents the slope, it is negative. Now, in an acceleration time graph, we could observe that it has a negative 2 constant line. In summary, in a velocity time graph, if we have a negative constant acceleration, it will have a negative slope. Likewise, it will also have a negative curve approach in a position time graph. Now, this time let's try to observe both velocity and acceleration, which is negative. We position the man at 7 meters. The velocity is negative 1 meter per second as the initial velocity, and the acceleration is negative 3 meter per second square. Let's try to observe the position time graph. As you can see, the man is speeding up at negative direction. Okay? He's speeding up because simply we have negative 3 acceleration. Notice that on acceleration time graph, we can see that there is a constant line at negative 3 meter per second square. In a velocity time graph, observe that it starts first at negative 1 meter per second, then it has a negative slope. And on a position time graph, it is curved but in a negative approach. So therefore, this will how you compare the position time graph, the velocity time graph, and the acceleration time graph if we have negative velocity and negative acceleration. Now this time, let's try to analyze our distance versus time graph. So we have here the displacement versus time. We have segment AB, BC, CD, and DE. First question is, which segment shows that the object is not moving? We have to look for a constant slope. So the answer is CD. How about this? Which segment shows that the object is accelerating? So we're looking for a curved graph, curved positive graph. Therefore, the answer is segment AB. How about this one? Which segment shows that the object is going back or we have a negative direction? So we have to look for a negative slope, and definitely the answer would be segment DE. How about this one? Which segment shows that the object is moving at positive constant velocity? Definitely the answer is segment BC. Now, what is the velocity at segment CD? Since we all know that the displacement is not moving, okay, the object stays at a certain position, therefore the answer is 0 meter per second. How about this velocity versus time graph? So we have this portion A or area A, we have this portion B, portion C, portion D, and portion E. And we have this 2, 4, 6, 8, 10, 12, 14, 16, and 18, and 20 seconds. And then this will be our velocity versus time graph. This is the first question. Which portion shows that the object is not acceleration or it has a constant speed? So once we say it is not accelerating, or meaning to say it has a constant speed, so we have to look for a flat line. So therefore the answer is portion C, from 8 seconds to 12 seconds. How about this one? Which has greater speed? Is it area A or area D? Now, what we're going to look is the value of the slope. Which one is steeper? Definitely that is area D or portion D. How about this third question? What is a time interval where both the velocity and acceleration is negative? So meaning to say, we have to look for negative velocity and negative acceleration. Therefore, the answer is 17 to 19 seconds. Okay? How about this time? At which time shows that the object shifted its direction from right to left? So meaning to say, the object turns from right direction going to left. Okay, it goes backward. Okay, the answer is 17 seconds. Next, what is the acceleration of the object at area D? So this is the area D. Let's try to analyze. So our value of the slope is simply this x sub 2, and then this is the y sub 2, and then this is x sub 1, and then y sub 1. So simply we have our 25 minus 15, that is our y sub 2 minus y sub 1, or velocity final minus velocity initial, divided by 14 minus 12. And therefore, we have 10 divided by 2, and the answer is simply 5 meter per second square.